on with balancing of chemical equations. Our next question is now, potassium hydroxide combines with carbon dioxide to give you potassium carbonate and water. How many potassiums are on this side? One potassium. How many oxygens? There's one in potassium hydroxide and two in carbon dioxide. You know, when you have the same element in more than one reactant or product, you would like to write them separately so that when you multiply, you're going to multiply only one of these. So you would know how you come to the end result. On this side also, we have oxygen in the two products. So we deal with that later. Hydrogens, how many hydrogens on this side? One hydrogen. And how many carbons on this side? There's only one carbon. Similarly, potassium, how many do you have? You have two here. How many oxygens? Oxygens are 3. Again, it's present in two products. 3 plus 1. And hydrogen, there are 2 hydrogens. And carbon, there's only 1. Now what do we see? Carbon is balanced. Hydrogen is not balanced. Potassium is not balanced. If I multiply, look, potassium, if I go oxygen, I would leave it till the end because it's present in more than one reactant and more than one product. Therefore, it would be best to deal with it in the end because that will bring the final changes. But first, let's try and balance the other elements. So let's balance potassium first. There's only 1 here and 2 here. So if I multiply this by 2, which means I'll have to multiply this by 2. If I do that, then 2 potassium hydroxide should give me, if I multiply potassium, automatically oxygen gets multiplied by 2 and the hydrogen also gets multiplied by 2. So this will become 2 on this side and this also becomes 2 here. Right? Now this is 2. Let's move ahead from here now. Potassium, 2 on this side and 2 on this side are balanced. Oxygens, there are 4. Okay, 4 on this side and 4 on this side. That's balanced too. Hydrogens, there are 2 on this side, 2 on this side, and carbons, 1 on each side. I think we've achieved the balancing. The equation is now balanced. 2 potassiums, 2 oxygens are 2 plus 2 would be 4, and 3 plus 1 is also 4, and 2 and 2, 1 and 1. Balanced. The next question. You have P4 and oxygen giving us P4O10. How would we balance this? They are 4 phosphorus atoms, 2 oxygen atoms. And on this side, also you have 4 phosphorus atoms, which means phosphorus is balanced, and oxygen is 10. If oxygen is 10, it means on this side, I need 2 to be converted to 10. So what do I multiply this with? If I multiply this with 5, this would be equal to 10. So what should I do? Where is the oxygen? If I multiply this by 5, I now get 5 2s are 10. Therefore, the oxygens are balanced and phosphorus was already balanced and hence the equation is now balanced. Silicon dioxide now combines with carbon to give silicon carbide and carbon monoxide. Silicon, 1. How many oxygens are here? 2. How many carbons? 1. Similarly here you have 1 silicon. How many oxygens? 1 oxygen. And how many carbons? 1 carbon. No, 1 plus 1. Carbon is present in 2 elements, 2 of the products. So 1 plus 1. Now in order to balance the carbon, we should multiply this by 2. Silicon is already balanced and oxygen, we always leave oxygen and hydrogen till the end. So let's balance carbon. If we multiply this by 2, I'll get a 2 here. So the carbons would be balanced, right? But oxygen, I have only 1 on this side and I have 2 oxygens on this side. In order to balance the oxygen now, I should multiply this by 2. But if I multiply this by 2, here, 2 carbon monoxides, the oxygen automatically gets multiplied the carbon automatically gets multiplied by 2, 2. So carbon becomes 3 on this side. Do you see? Now instead of 2, I have 3 carbons on this side, which means this was already multiplied. It was not the original number. So I can, if I have to convert this into 3, instead of multiplying this by 2, I get 2, silicon 1 here. If I multiply the carbon, instead of 2, I multiply it by 3, here I get my answer. Do you see this? So it's silicon, 1 silicon, 2 oxygens, and 3, 2 plus 1, 3 carbons. Yeah, the equation is balanced. Next, aluminium reacts with H2SO4 to give you aluminium sulfate and hydrogen. How many aluminiums? 1. Hydrogen, 2. Sulfur, 1. Oxygen, 4. Aluminum, 2. Sulfur, when you have this parenthesis, the bracket, you have to multiply all the components inside the bracket with the subscript outside the bracket. So sulfur would be 3. Oxygen would be 3 4s are 12 oxygens, and hydrogen are 2. Alright? So now you have 1 sulfur here, aluminum is 1 and 2. This 2 can be multiplied here. Okay? So the aluminum is balanced for the time being. Come to sulfur next. There are 3 sulfurs on this side and there's only 1. So if I multiply this by 3, if I multiply this by 3, it changes others also. How does it change? Sulfur, I got 3, but hydrogen, I'll get 6. 2 into 3 would be 6 hydrogens now. And oxygens would be 4 3s are 12. Oxygens are balanced, look. Yeah. Now hydrogen is unbalanced, all others are balanced. See? Now from this I got 2 aluminiums, 2 balanced. Sulfur 3 and 3 balanced. And oxygen is 12 and 12 balanced. So hydrogen, what should I do? To convert it into 6, I should multiply this by 3 to make it 6. So 3H2. In this equation, I get 2 aluminiums, 6 hydrogens, 3 sulfurs, and 12 oxygens. And hence, my equation is balanced. Now, in part 3, I'll solve 1 or 2 more problems, and then we'll conclude balancing of chemical equations. Keep practicing as much as you can. It really helps. Thank you.